Okay guys, so here's what you're going to do. Okay, we're going to make this into a bit of a lab. You're going to investigate energy conversions here. This is basically about practicing doing energy conversions between gravitational and kinetic. Okay, so if I switch, the first thing I need to do is switch on the grid, and I'm going to click the option here to turn on the speed because I want to be able to measure that. I also have a tool here that's going to allow me to measure the potential gravitational energy, that's what potential is, and the kinetic energy will also be able to be measured. I'll leave friction off for now. We might add to that later on. Okay, first thing I'm going to do is I'm going to choose height for my skater. Before I do that, I'm actually going to click slow and I'm going to click pause before I start. Okay, I'm going to pause the whole simulation before I begin. So I'm just going to start maybe somewhere around here. I'm not really sure what height that is, so I'm just going to take my measuring tape, which is here. I'll pop that down there like that and swing it up this way and put the crosshairs on the little red dot that's there. And it looks like my initial height is 3.4 meters. So let me change that. That's 3.4 meters. The mass of my skater is 60 kgs, but your one will be different because you're going to choose the mass of your skater. Okay. Next thing I want to do is calculate her gravitational potential energy. So I'll do this here on screen for you. You will do this in your notes and you'll pop up your answers in the table. So her gravitational potential energy is mgh. Her mass is 60 kgs times gravitational potential energy. We're taking it to be 10 newtons per kilogram. Times a height of 3.4 meters. Okay, so that works out to be 2040 joules of GPE. So I'll pop that one into my table now. Now when I go to measure it, don't be too surprised if the measured value is not actually the same thing. And the reason is that the simulator uses 9.8 instead of 10 for gravitational field strength. But that's okay. Okay, so the next step is to let her go. Okay, so all I'm going to do now is I'm going to press play, and you'll see those little purple dots come up along, and then they'll disappear once she's done one full period. She's gone all the way over to the other side. So I'll just pause her there. I'm just going to move the tape out of the way, and if I move the little tool over onto one of those dots, you can see it's giving me a measurement. Okay, and the first thing is you see that the height is 3.4 meters according to that, and she's actually already got a speed of 4.4 meters per second, which means I have not measured my height correctly by the looks of things. So that's okay. We'll let that run for a little sec longer. Okay, so our height is 2.4. Now the bit I'm actually interested in up here is the potential energy gravity. We predicted it to be 2040, but the meter is predicting it to be just over 2000. And if you notice, it's got 16.8 joules of energy at that point as well. So I must have mismeasured the initial point, but that's okay. So I'll pop in the potential energy. That's 2003 joules. And now I'm going to aim for the maximum kinetic energy. So the predicted maximum kinetic energy from my calculation is going to be the same as the gravitational potential energy. So my prediction, if she converts all of her energy over to kinetic energy, is that she will have the same value. She will have 2040 joules of kinetic energy at the bottom. Of course, now if I double check that with my simulator, You can see the height is 0, the speed, it's even giving me a measure on the speed. And you notice that the kinetic energy is actually a little bit off, but we expected that in the first place. So the kinetic energy there was 2018. So I'll just pop that in, 2018 joules. That's okay. Now, and here comes the real bit. This is the bit that you really need to focus on, which is predicting the final velocity, or the velocity at the bottom. And you can already see that we have a speed here and we have a speed up here on the little speedometer up the top. But we need to be able to do it mathematically, and that's the tricky bit. So there's a couple of ways we can do it. We can already take the gravitational potential energy, which we've already got, and let that equal to the kinetic energy, which is a half mv squared. We know that that's going to be 2040 joules. If I rearrange for the velocity, then that gives me twice the gravitational potential energy, which is 2040 joules, divided by the mass, and take the square root of the whole thing. And of course the mass here is 60 kgs. By the time we work that out, calculation wise, that works out to be 8.26 meters per second. Okay, so I'm going to pop that into my predicted velocity, 8.26 meters per second /x. The actual velocity is slightly different, and again, that shouldn't be any big surprise. It's 8.2, and again, the reason for that is gravitational field strength is ever so slightly different according to the simulator. Okay, so that's what you have to do. Okay, what I'd like you to do is do this basically over. You don't have to pick a mass of 60 kgs. You can pick your own mass, you pick your own height, you calculate the gravitational potential energy using the calculation. Then you just check using the simulator, and that's perfectly fine if it's a little bit off. You calculate, or you predict, the kinetic energy maximum, and of course that will always be the same as the gravitational potential energy at the top point. And then you use the little probe here to check what the kinetic energy is going to be at the bottom. And then you predict the velocity using our calculation, and then measure the actual velocity. Now I want you to do this multiple times, okay? I want you to change the height. So start off maybe at a low height, and then increase the height. Don't forget to double check your height using the measuring tape tool that's there. You could maybe use the grid reference as a guide, so you could go 1 meter, 2 meters, 3 meters. As you do them, all I want you to do is just hit return once you've completed one line. Keep your mass the same. You can even change the mass and see what happens, okay? See if the mass has an effect if you want. But change the height, that's the most important thing for now, and calculate the final velocity of the object, okay? Okay, hopefully that makes sense, and we'll see how that goes.